And welcome, student, to our second lesson in arrays. Today we're going to talk about the length instance variable. So, in Java, an array is considered to be an object, and like other objects, it might have instance variables. As it turns out, though, an array only has one public instance variable, which is length. So we don't have to worry about a bunch of other ones. There's only one to worry about. Now, this instance variable is automatically set to the size of the array when the array is created. For example, if we create an array in array as follows, double score equals new double 5, then score.length has a value of 5. And we kind of could establish this from last time when we started talking about how to create an array. Now, the length instance variable can be used to make your program clear by replacing unnamed constants such as 5, whose meaning may not be obvious, with a more meaningful name such as score.length. The array of scores 2 example is updated to show this. So if we look here, here is my array scores class from last time. And you can see both of these are still set up to say double score equals new double 5. However, when I give my prompt, you'll see that instead of saying enter 5 scores, it now says enter score.length. So it's getting whatever the length of the array is and returning that. Now that's a pretty easy example there to see how it works, but where it comes more in handy here is in the for loops. So in here, we say, for example, index 1, index is less than score.length. And down here you'll see before we said index is less than 5. So even though they're the same thing, the instance variable cannot be changed by our program other than creating a new array with another use of new. Right? And this is kind of advantage over using, let's say, a variable like we did in our labs, is that a variable we could accidentally somehow later go on and change it, and that could affect the length that we're checking against. Whereas if I just return the name of the array, so in this case score.length, it's not something that can be changed. So for example, the following would be illegal. Score.length equals 10. I can't change the length. It's always going to be whatever that length it was, and in this case it's 5. So we don't have to worry about accidentally overwriting that. Now here's a quick tip. We want to use for loops with arrays. So the second for loop in array of scores 2 illustrates a common way to step through an entire array using for loop. For index equals 0, index is less than score.length, index plus plus, system out println score index plus differs from max by plus max minus score index. Pretty straightforward. Now, the for loop is ideally suited for programming array manipulations. Now, that aside, let's talk about one of the first pitfalls, which is that array indices start at 0. The indices of an array always start at 0 and end with the integer that is 1 less than the size of the array. An additional pitfall to talk about is array index out of bounds. And we've kind of talked about the last one that they always start at 0 because you got to make sure you think it's like, even though it's 5, it's actually n minus 1. This is one that we also kind of talked about a little bit in lab in class, is that if you have, when we did our lab, like the first array was set to size 5, but the second one was user input, and if we had made our user input one larger than the first one, we end up crashing the program. And this is the same one that we talked about, which is array index out of bounds. This is the most common programming error made when using arrays, is attempting to use a non-existent array index. For example, consider the following: int a equals new int 6. When you're using the array a, every index expression must evaluate to one of the integers 0 through 5. So for example, your program contains index variable ai. The I must evaluate to one of the 6 integers 0, 1, 2, 3, 4, or 5. If I evaluates to anything else, that's an error. When an index expression evaluates to some value other than those allowed by the array declaration, the index is said to be out of bounds. And that's the error that we get, is an out of bounds error. If your program attempts to use the array index that's out of bounds, then your program will end with an error message. Now note, this is a runtime error message, not a compiler error message. You compile your code, it works great, it looks fine. But when you go actually to run your program, that's when you'll run into the error. That's why it's called a runtime error. Now, array indices get out of bounds most commonly either at the first or the last iteration of the loop that processes the array. So it's either going to happen right away or it's going to get to once it's completed the entire array, but it will crash. So it pays to carefully check all array processing loops to be certain that they begin and end with legal array indices. This is very important. Out-of-bound errors are very easy to correct, because usually it's like you may go too far or it's not far enough. And it has to do with, we talked a little bit like memory and stuff like that previously. If you have an array of size 5, let's say, and you look for array at element 6, well, 6 doesn't exist because the last value is technically 4, because we're going to go 0 to 4. So you're asking it to look beyond where the array is. So it's like, okay, 0, 1, 2, 3, 4, and it crashes because there's nothing for it to go beyond there. You're telling the reference pointer for that array to look someplace where there's non-existent data. All right, let's initialize some arrays. An array can be initialized when it's declared. We actually don't have to wait to put values in. When initializing an array, the values for the various index variables are enclosed in braces and separated with commas. The expression of the braces is placed on the right-hand side with an assignment operator. So, for example, int age equals 2, 12, 1. And that's how you initialize one. Simple as that. The array length size is then automatically set to the number of values in the braces. So initializing this declaration is equivalent to the following statements. Int age equals new int 3. Int age of 0 is 2, age of 1 is 12, and age of 2 is 1. You can also initialize array elements using a for loop. Double reading is new double 100 into index. For index equals 0, index is less than reading dot length, index plus plus. Reading index equals 42.0. Now, automatic initialization. If you do not initialize the elements in an array, they will automatically be initialized to a default value for the base type. So even if you don't fill it in right away, you don't give it those initial values, it's okay because Java is going to try to do it for you. So for numeric types, the default value is the 0 of the type. So it's int, double, float, whatever. For a base type of char, the default value is the non-printable 0th character, char 0, not the space character. Very important to note, not the space character. Space character is actually different. It's a non-printable 0th character, which is a chart 0. Again, it's a character that you wouldn't be able to print off on your keyboard. Now, for the type Boolean, the default value is false. And then for class types, the default value would be null. So if you're looking at, if you were to create a class array, the values that we filled in would be null. So for example, we do not initialize the array of doubles, each element of the array will be initialized to 0.0. All right, and that's going to wrap up today's notes for today, folks. So until next time.